Welcome to the flock. Let's dive into using Google Sheets to do some basic, repetitive, monotonous, tedious calculations for you so you don't have to do them by hand, and then using those calculated values to make a lovely graph. Stick around to see how it's done. Before we can calculate for something in Google Sheets, we first need to understand the equation that we'll be using so that we know how to program the equation into Google Sheets and tell it what to do for us. In a recent experiment I conducted where I collected hydrogen gas, we found that the pressure of the area that the lab was conducted in was 1025.4 HPA. But we need to do a bunch of calculations with new HPA pressures and convert them into ATMs first. We could either waste our time and do these all by hand individually, or we could just do one and then use that logic in Google Sheets and have it calculate the rest for us. So let's first figure out what the conversion factor is between HPA and ATMs. One ATM is equivalent to 1013.25 HPA. We can use this fact to convert our first new HPA pressure value to ATMs. If we start with our given value of 1030 HPA, we know that our HPA values will need to cancel. So we're going to keep one ATM on top and put our 1013.25 HPA on the bottom. This way we can see that the HPAs cancel and we are left with units of ATM. So all we have to do now is take our 1030 and divide it by the 1013.25. There's no number on top other than this 1 to multiply by, so that's just going to be the same value anyways. So let's just focus on that division. So when we divide the top and the bottom, we end up with the result of 1.016 ATMs. Now, we could go through and divide each one of these new pressures by our conversion factor and do that all by hand and waste our time. Or we can just plug this into Google Sheets and have it calculate the rest of these values for us in a snap. Let's apply the same logic we just saw by hand to the Google Sheets. In order to tell Google Sheets to calculate something for us, we need to click on the box we want the calculation to occur in. You see, I've already transferred the HPA pressures here. I've already written them down. I want Google Sheets to give me the new ATM pressure units here when it calculates them in this column. So what I'm going to do is click on this first box, and then I'm going to click on the keyboard the equal sign. That equal sign tells Google Sheets, hey, I want you to calculate something for me. Well, what do we want it to calculate? We want it to take this value over here and divide it by the 1013.25 HPA in order to have units of ATMs. That's what we kind of wanted from the get-go, as we saw in our handwritten calculations. But if I do it this way, it's only going to calculate for A2. That's box A2. So just for the 1030. I want it to do all of these. So all I did now was left click and drag. So I held at the top, left click, and dragged down. That dragging tells it specifically which values I want it to pull from in order to do the calculations. You could have also just left clicked on the top here on the A column and it'll highlight everything that you have in that column. This is a lot easier to do, especially if you have a lot of values to convert and not just 10. Then, as we saw in our handwritten calculation, we needed to take that value and divide by, so now I've hit my diagonal slashy bar on the keyboard to indicate division. I'm going to divide it by, in parentheses, 1013.25 HPA. Don't include any units here, so don't write HPA because that's going to confuse the calculator in Google Sheets. We just want numbers. So I'm going to close my parentheses now because I know that that 1013.25 is my HPA value conversion factor. Now if I hit enter on my keyboard, you'll see it gives me the value, the 1.016 that we calculated before. Now I can carry this calculation by clicking on this little box in the bottom corner of the top and dragging it where I want the calculation to be applied to. Ta-da! Instead of having to hand divide every single one of these pressures, Google Sheets did it for me. You can double check and make sure that your calculator is still correct by double left clicking on this box. And you can see that it did in fact pull this value, the 1060, and divide it by the 1013.25. When we clicked and dragged this little bottom box, we essentially told Google Sheets apply that same calculation setup to all of these values all the way down. Let's try a little bit more of a challenge on an equation for calculating the new volume of H2 gas now. When we want to calculate this new volume of H2 gas over here, we're going to use Boyle's law for the purposes of this example. You might have a different equation you need to plug in, but Boyle's law is equivalent to P1 V1 equals P2 V2. So the initial pressure times the initial volume is equal to the final pressure times the final volume. We're trying to find the new volume of the gas, so that's kind of like our X that we're solving for. And we know that the new pressure of the gas is going to be the stuff we calculated in these boxes here. So basically our converted pressure in ATM. So we're going to need to tell Google Sheets to take whatever is in this column and plug it in here for our equation. The original pressure that the lab was conducted in was the 1025.4 HPA. Of course, we need all of our units to match. So using the same conversion setup we did for all of these, if we divide the 1025.4 HPA by the 1013.25 HPA value, we end up with ATMs of 1.01199 over here as our initial pressure. And the initial volume of hydrogen gas that I collected from this lab experimentally was 262 milliliters, or 0.262 liters. I want to make sure it's in liters so that my units match what I'm trying to calculate for. This side over here of the equation is going to remain constant throughout our equation, so we can just multiply those two values together so we only have one number to manipulate in Google Sheets. When I multiply those two numbers, I get 0.26514,138. And that would be set equal to all of the new pressures we already calculated in the Google Sheets times X. But to get X alone, we're going to want to divide off all of those new pressures we calculated in Google Sheets from both sides. So let's divide our new ATM from this side so that it would cancel here and X would be alone. And we would divide this side by our new pressure in ATMs. So essentially what we're plugging into Google Sheets is this number divided by all the stuff in this column to get our new volumes in liters. So just like before, we need to tell Google Sheets that we want it to calculate something for us. We're going to click on the box where we want the calculation to occur. In this case, we want volume of H2 gas, the new V2, the new volume. And we're going to still click the equal sign from our keyboard to tell Google Sheets we want to put in an equation now. So for our numerator, we just need to write in the 0.26514,138 that we calculated for previously, and I'm going to put that in parentheses. And we found that that was divided by, so the slashy key on your keyboard, all of the stuff in our B column, because that was our new pressures in ATM. Let's hit enter on our keyboard. After we hit the enter key on our keyboard, we see that Google Sheets has calculated our new volume of gas in liters, according to our new atmospheric pressure. Same as before, we can click this bottom right-hand corner box, hold, and drag down in order for the calculator to calculate the rest of the new volumes for us instantly. Now, for the purposes of the lab that I conducted, I would want to graph this data now and see if I had a direct or an inverse relationship between the volume and pressure. So I'm going to left click, hold, and drag down the two columns that I'm interested in graphing. Then I'm going to go up to the top, click on Insert, and Chart. A lot of times Google Sheets isn't smart enough to put in the right chart that you intended. So we actually want a scatter plot, not a column chart. So I'm going to go up here to Chart Type and scroll down until I can get to Scatter Chart. There we go. That looks better. Next, I want to make sure that my volume is on the y-axis and my pressure is on the x-axis. If we look at our values, these are all in 1 to 2 range, and that definitely appears to be on the correct axis. We need to label it though, because this is a very naked and ugly graph without labels. So over here in the chart editor box, we're going to click on Customize, and then we're going to go to Chart and Axis Titles. In this drop-down menu, we see Horizontal Axis Title. Horizontal meaning the x-axis. So we're going to title that one first. The x-axis we know is the pressure in units of ATM. Now we see the beautiful little label pop up on the x-axis. Well, we can't just leave the y-axis alone. That's our vertical axis. So click on vertical axis and put in volume of H2 gas in liters and hit enter. Last but not least, we need a title for the overall graph, so we're going to go to chart title. And the chart title would always be in the format of Y versus X. I also like to write graph 1, so if I had this in a lab report, I could just refer back to graph 1 when I'm talking about the summary or conclusion, instead of writing out the entire long title every single time. In this case, it would be volume of H2 gas versus pressure. So now that we have this beautiful graph, we also need to figure out what kind of relationship those data points possess. In order to do so, you can left click on any one of the data points twice quickly. When you do so, you'll see the series part highlighted in your chart editor. Scroll down until you can get to trend line. Click on trend line and you'll see it automatically applies a linear type line. Now, we need to know if that's actually a good fit for this data, so we're going to show the R squared. Anything that's close to 1 for R squared is a really good fit for a line. Notice this is 0.976. Not too shabby, but there might be something better. So instead of a linear line, let's try an exponential line. Ooh, our R squared jumped to 0.994. That's way better. Let's see if we can get it even closer to 1. If we click on polynomial, we get 0.999. Whew, even better. Let's try logarithmic next. Logarithmic gives me 0.994, so not as good as the other ones. Let's try power series. Power series literally gives us an R squared value of 1, so we know that this is the closest fit to our data. Now, in terms of the lab I conducted, determining whether something was a direct or inverse relationship, we know that what we calculated for was Boyle's law, and that's an inverse relationship. In other words, as the volume goes down, the pressure goes up, or as the pressure goes down, the volume goes up. It's inversely related. And what we can see on this graph is a downward sloping power series line. That slope, the power series, tells us, yes, in fact, this is an inverse relationship. If it was closer to an R squared value of 1, as a straight linear line equation fit, then we know that would have been more like a direct relationship, where one would go up, so would the other, or vice versa. But in this case, the graph we've constructed from the calculated data supports the fact that Boyle's law is an inverse relationship. In this video, we learned how to take a handwritten calculation and plug that calculation into Google Sheets in order for it to calculate multiple tedious calculations for us in a snap. You always start by putting an equal sign in the cell that you're interested in getting your calculated value from. Then make sure you click on wherever the value is that you are interested in plugging into the calculation and using your handwritten equation setup for the logical setup in Google Sheets. And then we also saw how to use that calculated data to create a beautiful graph. Please give this video a quacks up, and when you're out of luck in chemistry or in Google Sheets, subscribe to the Duck. Quack you later.
No ducks, no glory.